We're going to go back and take a look again at our absolute value inequalities. We're going to look at how we use the two rules for our greater than and for our less than. And I'm going to have you work a few extra problems on those. Okay, let's review our two sets of rules here. If we have x plus b inside the absolute value greater than our constant, we will split it into the inside is less than the negative constant, or the inside is greater than the constant. And if our absolute value of x plus b is less than c, we will split that into our inside is less than the constant, or our inside is greater than the negative constant. Let's also review how we solve the inequality. You can solve your absolute value inequality using those same methods that we used to solve the absolute value equations. Alright, so remember the first thing we always do is we isolate the absolute value expression. We rewrite the absolute value expression as our compound inequality, and then we solve each of those two compound inequalities for our x. Alright, let's take a look at our first one. So we're going to take our first one. We have the absolute value of a negative 4q plus 2 greater than or equal to 10. Is our absolute value isolated already? And the answer to that is yes. So our first step will be to rewrite, and we will split it up. We are going to use our greater than two rules. So our inside will be less than the negative, which is this one here, and it will be greater than the positive, which is our second one here. So we would then proceed to solve both of those inequalities separately. We are going to subtract a 2 from both sides of the inequality, from here and from here. So 10 minus the 2 gives us an 8, and the negative 10 minus the negative 2 would give us our negative 12. And then we will finish out by dividing both of our inequalities by the negative 4. And remember what happens when we divide both sides of an inequality by a negative. We have to reverse our symbols. So in this case, the 8 divided by the negative 4 here gives us a negative 2, and our inequality symbol gets reversed. And over here, when we divide out by that negative 4, our inequality gets reversed. It goes now to greater than or equal. And then a negative 12 divided by negative 4, there's our positive 3. Now let's take a look at our graph. If we have q less than or equal to negative 2, we are going to have a closed point. Those points less than going to negative infinity, and our 3 will also be a closed point because of the equal sign, and greater than will be on to positive infinity. And there is your graph. Let's take a look at another one. And here you can come down here and test just to make sure we have it. Our next one we're going to solve is the absolute value of 2x plus 7 over 3 less than or equal to 1. So when we are looking at this, we do realize that, in fact, we are not isolated. We must get rid of that 3, and so we will get rid of that 3 by multiplying both sides. And when we multiply both sides by that 3, these will cancel here, and 1 times 3 would give us 3. Now we're going to focus on our less than or equal, so we will follow our second rule right here. So we will rewrite. So we will have our inside at 2x plus 7 less than, and we will include the equal, our constant at 3, and our 2x plus 7, our inside, greater than the negative constant, or in this case, the negative 3. So we would proceed to solve both of these. So we will subtract the 7 from both sides on both of them. So we would end up with 2x less than or equal to negative 4 here, and 2x greater than or equal to, we're going to add the 3 and 7 for a negative 10. Divide those out, and we get our inequalities. We end up with x less than or equal to negative 2 here, and x greater than or equal to negative 5 here. We will go then and graph those. And if x is greater than negative 5, so we include our point in this close point, we're going to head in this direction. But if x is also less than or equal to negative 2, we're going to go back to the negative, and we end up with a small interval here, which is our solution set. Okay, that is the end of your slideshow. I'm going to post an additional worksheet for you to work on, and that will be due at the beginning of class.